Today we're looking at basic trig equations where we're using radians rather than degrees. We're going to do two examples, one on calculator and one calculator. The first example, 4 equals 5 minus tan 2x, and we are given a domain between 0 and pi. So we're going to start by just rearranging the equation so we can get the tan x on its own. So I'm going to add tan 2x to both sides, and I'm also going to subtract 4 from both sides. So that will leave me with tan 2x being equal to 5 minus 4. And so tan 2x is going to be equal to 1. We're going to need to find the inverse tan of 1, and that will give us the solutions. However, there's going to be more than one answer, so we're going to use our cast diagram. Our tan, the tan of this is positive, so therefore we're looking for quadrants where tan is positive, and it's positive in quadrants 1 and 2. Now quadrant 1 is theta, and we always find that from either using the calculator or your exact values. So the inverse tan of 1, we can actually do this one from an exact value triangle. And the tan is TOA, opposite over adjacent, is 1, which means it's 45 degrees. However, as we can see in the question, we're actually wanting to work in radians. So I would suggest that at this point you change to radians and work through the rest of the question in radians. Now we just need to remember that pi is 180, and we can work out everything else from that. So 45 degrees is a quarter of 180, so that means it's a quarter of pi, or pi over 4. And that's us found the first angle, and that is in quadrant 1, and we want that one as one of our answers. The next one we want is in quadrant 3, and normally to find this one we would add 180 degrees. We're working in radians, so that's going to be pi that we're going to add on. So we've got our first answer, which is pi over 4, and our second answer, which is pi over 4 plus pi, so that's 5 pi over 4. And remember, that's because pi is 4 quarters of pi, and we're adding on one more quarter, which gives us 5 quarters. Now, we're going to look at the next solutions, whether or not we're going to need them, just so that we know how to do it. Here we're looking at values for 2x, so that's going to prompt me to, once I've found the solutions within 360 degrees, I want to find the next two solutions. And to do that, I simply add 360 degrees, or in this case, I'll add 2 pi. And I'm going to think of the 2 pi in terms of quarters, so that it's easier for me to add. So I've got 8 quarters of pi that I need to add on to each of those. So 8 quarters plus 1 quarter is 9 quarters, and 8 quarters plus 5 quarters is 13 quarters. So I now have 4 solutions for 2x. To find x, I just half each of those. To half a fraction, I just double the denominator. So pi over 4 halved becomes pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. And now at this point, I go back and I check the range that I was given, and it's between 0 and pi, so we can see here that I'm not going to need those ones because they are out with what the question is asking for. And so our final solution is just going to be pi over 8 and 5 pi over 8. So that's a non-calculator example. We'll now go on and look at a calculator example. Remember, for this one you're going to need to change the mode on your calculator, change it to radians instead of degrees. And we'll start in the same way, so we're just going to solve the equation till we can get the sine part on its own. So I'm subtracting 2 from both sides. So I've got 4 sine t is negative 2.35. And then I'm dividing by 4. And sine t is negative, and that would be 0.5875. And now I'm going to use my cast diagram to check which quadrants I'm interested in. So we can see here that the sine of the value t gives us a negative answer. So we are looking for quadrants where sine is negative. Now, in the first quadrant everything's positive, so it can't be there. In the second quadrant sine is positive, so it can't be there. Third quadrant only tan is positive, which means sine must be negative. And in quadrant 4 only cosine is positive, so sine must be negative. So we are looking for quadrants 3 and 4. And although we're only looking for 3 and 4, we're actually going to use quadrant 1 just to find the acute value that we can use to find the values in quadrant 3 and 4. So in order to find that acute value, theta, we're going to do the inverse sine of 0.5875, and that's a positive in this case, will give me the acute angle, which is 0.62796598, etc. So let's say 0.63. And so then to find quadrant 3, I'm going to add 180 degrees, but we are working in radians, so we're going to add pi, and that will give us the first solution for t. So t equals 0.63 plus pi, which gives us 3.77, and that's in quadrant 3. And quadrant 4 is quadrant 4 is 360 minus the theta. Well, we're working in radians, so that's 2 pi minus 0.63, which gives us 5.66. And then we want to check the next solutions, because our range here actually takes us up to 4 pi. So we're going to add 2 pi to each of those numbers, and that will give us final solutions of 3.77, 5.66. We add 2 pi to each of those and we'll get 10.05 and 11.94. And that's the final solutions for that question. Remember to change your calculator back to degrees, and if you've got any more questions, just ask online.